Today we're going to be multiplying and dividing rationals. Recall that A times C over B times C can be simplified. Since we're dividing C by C, anything divided by itself is 1. So this C can cancel out this one, and we are left with A over B. We will use that property quite a bit here to simplify our rationals as we move to multiply and divide. On our first one here, we are multiplying these two fractions. And remember, when you multiply fractions with numbers, you multiply straight across the top and straight across the bottom. You do not need to get a common denominator to multiply and divide. So here we would multiply straight across and then multiply our denominator straight across. Before you do that, you can go ahead and reduce, and so we'll practice that later on, but I'll start with that one. So a squared times a gives us a cubed, and b times b squared is b cubed. With division, you need to remember the keep, change, flip. So we keep the first fraction, we change division to multiplication, and we flip the second fraction. Now we're ready to multiply, so we multiply all the way across. So a squared times b squared is a squared b squared, and b times a is ab. Now we can use that property to simplify this. We have two a's on top and one on the bottom, so this a cancels out one of those, and this b cancels out one of the b's. So we're left with a b. You would not want to leave a fraction as 4 over 2. You would want to reduce that to 2. Same thing happens when you're working with the rationals here. You're going to want to reduce them on the variables. All right, so we said we could get back. We know as we multiply across here, everything on this top is going to end up in the numerator, and everything we multiply on the bottom is going to be in the denominator. So you can go ahead and reduce earlier on. If something is in the numerator and the denominator, you can cancel it out. It makes some problems easier to work with. So for example, here we've got a 2x in the denominator and a 4x in the numerator. Those two can reduce before we move forward. 2x goes into 4x twice. So that can reduce. You could reduce the 5 and the 15 as well. 5 goes into 15 3 times. Now when we multiply across, we get 1 times 2, which is 2, and then 1 times 3, which is 3. So our fraction is 2/3. That allows you to reduce before the numbers get big and the variables have higher exponents. All right, the same is true when you have division, but you do have to do the keep, change, flip first. So we would do 3x squared over x plus 7 times x plus 7 over 12x cubed. So I have flipped my second fraction here. You always flip the second one. You keep the first one, change division to multiplication, and then flip the second one. So now we've got an x plus 7 in the denominator and the numerator, so that cancels out. That makes it a lot easier than multiplying 3x squared times x plus 7 and multiplying this one and this one to reduce afterwards. So this is where you definitely want to reduce as early as possible. We can reduce our numbers here as well. 3 goes into 12 4 times. And then you've got 2 x's down up on top and 3 x's on the bottom. So we can cancel out this x squared, and you can cancel out 2 of those, leaving just 1 x on the bottom. Since there's nothing left on the top, we know that's a 1, because anything divided by itself is 1. So that's what we have left. On the bottom here, the 1 times 4 gives us 4. So we get 1/4. All right, we're going to do the same thing now with some that are a little bit harder. So here it goes. This one has a bunch of variables. You're definitely going to be able to do either way that we talked at the top. You can start to cancel stuff that you see in the numerator and the denominator, or you can multiply across. In this case, sometimes it's easier to multiply across just because there's so many variables in this one. So it gets a little confusing with all the crossing out. So I'll go ahead and do that. I've got a b squared, x cubed, y squared, and z on the numerator. On the denominator, I've got an a squared times an a cubed, which is a to the 5th. Then we've got a b squared, x squared, and y. And then now I could reduce the b squared and the b squared are exactly the same, so that just gives me 1. I've got 2 x's on the bottom and 3 on the top, so I can cancel out 2 of those and that becomes a 1. And then I've got 1 y on the bottom and 2 y's on the top, so I can cancel that out. Now I've got x, y, z in the numerator and a to the 5th in the denominator. Those get a little confusing because you've got all this crossing out, so you want to be just careful with that. All right, on number 6 here, this one's a little bit different. It's got the plus and minus in between, so you have to be a little bit more careful with that. The reason why we can cancel these is because there's no plus or minus. So they're all being multiplied and then divided between each other. But here, order of operations would demand that you do this minus before you cancel something out. So this x would not cancel those x's. You can't do that stuff. All right, we are going to factor in order to get these to simplify. So I start by my keep, change, flip. So I'm going to keep that first one, change the division to multiplication, and then flip the second one. Now we're going to factor to see what we have going on here. So I've got 4x on the top, that doesn't factor. In my denominator here, I can factor out a 3. And so the 3 goes into both of those, so I get 3 times x would be that 3x. 3 times -4 would give me that -12. I can also factor the numerator here. I can factor out a 5 there. And then 5 times x would give me the 5x, and 5 times -4 would give me that -20. And the bottom can't factor. Now we can start to cancel stuff out. So you'll see that you couldn't cancel the way it was right here, but x minus 4 and x minus 4 are exactly the same, and they're being multiplied times this other part. So I can cancel those because they're exactly the same in the numerator and denominator. The 4x can go into this 16x squared. It goes into their 4x times. So that can reduce as well. And now we're ready to multiply. So on the top here, I had nothing left. So that's 1 times 5. On the bottom, we had a 3 and a 4x. So that is 12x. All right. Hopefully at this point, you're getting a little bit of a handle on what is going on, so we can start working on some of the ones that are a little bit harder. I told you guys before, you're going to have to factor quite a bit. Factoring is important, and so on these rationals, there's some of them where you'll have to factor 4 times. So make sure that you're caught up on your factoring. On this one, it's division, so we're going to keep x plus 9. And then we've got an x squared minus 8x plus 15. We're going to change division to multiplication, and then we're going to flip the second fraction. Now we're ready to get started. Nothing here can cancel the way it is, because remember, these minus and plus, you cannot cancel this right here. You would break order of operations. This whole term is together, this whole term is together. And so you would have to do those before you would do the canceling. So in order to do that, we have to factor this to check to see if there's anything that can cancel. When factoring this denominator, it's a trinomial, so I'm looking for what multiplies to be 15 and adds to be -8. Because x times x gives me that x squared. Then I'm looking for what multiplies to be 15, adds to be -8. And that is -3 and -5. I want to do the same thing for the second fraction. So I'm going to keep that numerator, and then I'm going to factor this denominator. X times x gives me the x squared. Then I'm looking for what multiplies to be -9 and adds to be 8. And that would be a +9 and a -1. 9 times negative 1 gives me negative 9. 9 plus negative 1 gives me 8. Now we can cancel something if it's in the numerator and the denominator. It has to be exactly the same. So we've got an x plus 9 and an x plus 9 here. And again, we can only do that because now they're being multiplied. We also have an x minus 3 and an x minus 3 here that can cancel. Nothing else cancels. So now we're ready to do our multiplication. 1 times 1 is just 1. And then x minus 5 times x minus 1. Oh, you can't see that. There we go. And so this could be or should be your answer right here. You can leave it in the factored form to show that nothing else cancels. You could multiply that bottom out as well. All right, we'll do one more of those. This one is a multiplication. So I do not have to keep change flip. I keep this exactly the way it is since it is multiplication. My first step would be to factor. Now this is the difference of two squares, and this is the difference of two squares. So that's that pattern rule. Anytime that we have a perfect square minus a perfect square, we know that it goes straight into those two factors, 2u minus 1 and 2u plus 1. And again, our denominator is two perfect squares. That's u squared, and that's 2 squared. So we get u minus 2, u plus 2. In our second fraction, none of those factors, so we're just bringing them down. Now we're ready to do our multiplication. So we find if anything can cancel in the numerator and the denominator. I've got a u minus 2 and a u minus 2 there, so that cancels. I've got a 2u minus 1 and a 2u minus 1 here, so that cancels. Nothing else will cancel, so I'm left with 2u plus 1 over u plus 2. Again, you cannot cancel these u's because we've got that plus there, and that would break order of operations. All right, we're going to continue now with our rationals, but get a little bit harder with the factoring. So that's going to be something big that you're going to have to get really good at as we move through these rationals. So x squared plus 4 does not factor, so I would leave that alone in the top here. In my denominator, I've got x to the 4th minus 16. That's the difference of two squares again. And so that is going to factor to be x squared minus 4 and x squared plus 4. Since x squared was being squared to give me this one, and 4 was being squared to give me this one. Now, when you get to this point, you have to recognize this factors again. So we would have to factor that further. You want to take it down to the simplest form. So that factors to x minus 2, x plus 2. Back in that factoring unit, I told you factoring was really important. All right, so now on our second one here, those are both trinomials. So x times x gives us x squared, and then we're looking for what multiplies to be 12 and adds to be 7. So that is 4 and 3. In my denominator, I get that x times x to give me x squared. And then I'm looking for what multiplies to be 16 and adds to be 8. And that is 4 and 4. Now that we've set up all of our factoring, and I'm going to just bring that down because nothing else factors on those. Now that we have factored all of them, we are ready to simplify. So I've got an x squared plus 4 in the numerator one and an x squared plus 4 in the numerator here. People forget to check up and down. They start checking diagonally and not check that way. But as long as it's in the numerator and denominator, it can cancel. So that cancels out. X plus 4 cancels that x plus 4. And that is everything that cancels there. So now, in our numerator, we're left with an x plus 3. So that's going to be my numerator. And then in the denominator, we have here an x minus 2, x plus 2, and x plus 4. And so that would be our answer. We can't go any further. You cannot cancel x's this way because there's that addition sign. So all of this together would stay together. All right, on number 10 here, this one's multiplication. So I'm going to start the factoring. In my numerator, I've got a trinomial, so x times x gives me that x squared. Looking for what multiplies to be negative 8 and adds to be 2, and that is a positive 4 and a negative 2. We've got the difference of squares, and this is one that's kind of confusing for students. They want to switch it around because the x comes next. But in the pattern, it is a perfect square minus a perfect square. So this would be 4 minus x, 4 plus x. Don't mess up those signs there. And then we're back to the trinomials, so I can set those up. X times x gives me that x squared. Looking for what multiplies to be 4 and adds to be negative 5, and that is a negative 4 and a negative 1. On the second one, x times x gives me that x squared. And then looking for what multiplies to be negative 10 and adds to be 3, and that's a positive 5 and a negative 2. Now, anything that's in the denominator and the numerator can cancel. Now, x plus 4 and 4 plus x are exactly the same thing. They're both positive, and so this will cancel this one. But here's where it gets tricky. In this case, the x is negative. In this case, the 4 is negative, so those are not the same, and you would not want to cancel that out. Now, the x minus 2 and x minus 2 cancel, and so we're left with x minus 4 times x minus 1. And then I'm going to go ahead and rewrite this with negative x plus 4 and x plus 5. This is the same thing as that, since the negative is still with the x and the 4 is still positive. The reason why I rewrote that is because if you look at this, they just have the opposite signs. So you can factor a negative out of this bottom one. If I factor out a negative, it would look like this. And so then x minus 4 and x minus 4 cancel. And my final answer would have x minus 1 on the top, and then it would have a negative times x plus 5 on the bottom. So this would be fully reduced. That's one that gets a lot of people. All right, these next ones are kind of just a little bit scary just because of the way they look, but it's still division. That's just one fraction divided by another fraction. So don't let that scare you. If it does, go ahead and rewrite it. So that's 4a squared minus 1 over a squared minus 4 divided by 2a minus 1 over a plus 2. Those two are exactly the same thing. They're just written a little bit different. We still keep the first fraction, change to multiplication, and flip the second fraction. Now we're ready to factor. That's the difference of two squares up here, which we did earlier. So that's 2a minus 1 and 2a plus 1. This is the difference of two squares, so that's a minus 2 and a plus 2. These two don't factor. And so now we're ready to cancel. We've got a 2a minus 1 and a 2a minus 1, so those cancel. And we've got an a plus 2 and an a plus 2, that cancels. So we're left with 2a plus 1 and a minus 2. There's our answer. Same thing goes for this one. So I'm going to start by keeping the first fraction. I'm going to change that to multiplication, and then I'm going to flip the second one. In this one, they're challenging you a little bit by changing the types of trinomials and giving you that a value. Those are a little bit harder to factor. We factored that earlier in the year by the box or slide and divide or the x, whatever form of factoring you do when there is an a value in front of the x squared. That's what you're going to have to do there. So this one's a little more time consuming. If you're using the box or slide and divide or something, you're going to have to do that off to the side for those three. But that first one factors to be 2x plus 3 times x plus 3. The numerator here factors to be 5x plus 2 and x plus 1. And then our denominator factors to be 2x plus 3 and 5x plus 2. Again, you've got to use one of your forms of factoring to factor those because the a value is not 1. Now we're ready to cancel. And so we've got a 2x plus 3 and a 2x plus 3, the 5x plus 2 and the 5x plus 2, x plus 1 and x plus 1. So almost everything cancels there, and it actually comes out to just be x plus 3. Some people find that satisfying, some people find it frustrating, but it does simplify down quite a bit. All right, I'm going to move over to number 14. This was probably the most challenging question you could get. This is a division one, so our first step would be to keep, change, flip. And so we start to factor on this one here. And the top part factors as a trinomial. We're looking for what multiplies to be -2 and adds to be -x. And so that would be -2 and a +1. The second one doesn't factor. They're already down to as simplified as possible. Now we need to factor this one, and I can tell that this one does not factor by grouping, so we need to think about something else. So you can use one of the values that you've got on the top here to do synthetic division. So this one's challenging in the fact that it makes you think through stuff that you've done in the past. And so we think it's probably going to cancel with this one, so I would start with that one. But you can try with these to see if one of those are a factor of this thing. So I'm going to start with this one. The root here is -3, so I go back to my synthetic division. Remember, with synthetic division, we go -3 in the corner there, and then we use our coefficients, 1, 6, -1, and -30. That's our coefficients for this one. I drop my first term. I multiply. -3 times 1 is -3. I add, multiply, add, multiply, and add. And we said that if it had a remainder of 0, then it was a factor. So we know that the x plus 3 is a factor. So the root was -3, so I know that's going to be an x plus 3. Now what's left here is x squared plus 3x minus 10 with the synthetic division. Now that it's a quadratic, we can go ahead and factor like we factored all the rest of those trinomials. X times x gives us x squared. And then we're looking for what multiplies to be -10 and adds to be 3, which is a +5 and a -2. Math is always growing on itself, so you've got to remember that stuff from the past just to be able to solve some of the problems. Now we have an x plus 3 and an x plus 3 that we can cancel, an x minus 2 and an x minus 2, an x plus 1 and an x plus 1. And so almost everything cancels except for that x plus 5 in the bottom. So this is 1 over x plus 5. That one was definitely more challenging than the others. So that would definitely be the hardest one that you get. All right, next time we'll be doing adding and subtracting rationals.